this course, there's a project required at the end of the semester, and you can form groups of up to 3 folks. Obviously, the more folks you have on the team, the complexity goes up linearly. And you're free to choose any topic, as long as you're within these boundaries. The requirements in this document, you don't need to ask me for permission what I think about your domain. As long as you're within these boundaries, you're free to do whatever domain you want. You are asked to support 2 types of users. It makes it harder to maintain the various relationships between users, their roles, and their associations with the domain objects. Domain objects are just that. They're depending on the domain that you choose. You need to model whatever data it is for that particular domain. If it's food or movies or recipes or whatever it is that whatever the particular domain you choose, the domain objects will be different for every one. Okay? You'll need to capture data for these types of objects, and so you can store it in the database. So, for instance, 2 types of user or 2 types of role would be one. For instance, somebody might be a student, somebody might be a faculty, somebody might be a buyer and a seller. If you think your idea escapes the boundaries of the requirements here, we can negotiate. Right? We can say, well, if you just don't want to follow these requirements, I'm open to that idea. Then you need to talk to me. Right? I just want to make sure that whatever you do choose to do is comparable in complexity. Okay. Or if you think that you're mostly going to be within boundaries, but perhaps you want to add another feature that is not listed here, then again we can negotiate. Right? It says, okay, well, instead of doing these 2 things, maybe you can do you can add some other feature. Right? Then we need to talk. Right? Just to make sure that the complexity is not too small, it's not too big. So again, you need to support at least 2 types of human end users. End users, as in folks that are the audience of this application. In addition, you need to support an admin user, somebody who has got power, somebody who can log in and edit everything, remove everything, or just has access to all the data. But 2 types of human users. So a seller and a buyer, a student and a faculty, a developer, quality assurance. So here's just 6 examples of different domains. And for each domain, you have a different set of types of users. Again, yours might be some other domain. And that particular user that you choose has to have a specific interface to interact with the domain objects. Right? Again, that adds to complexity. Right? Depending on who you are, you interact with them in a different way. Then you have the admin role that can implement all the CRUD operations with users. They can create users. They can create domain objects, remove them, edit them. Okay. So as an online movie social network, a system admin can create, read, update, and delete actors. They can create, remove, update, or delete domain objects and their relationships. You need to support login, some form of login. A very simple username and password login would be just fine. Okay. If you want to explore other mechanisms of logging in with some social networking, go ahead, but it's not required. The end user requirement. All right, so so you have to support at least 2 end users, and the interfaces have to be specific to each one of those users. If you join in a team, then the requirements go up a little bit, right? Any undergraduates here? No undergraduates? Okay, good. Awesome, great. So forget about this then. Graduates, if you have just one member, then you just have to support 2 roles, plus admin, plus anonymous users, and you need at least 2 domain objects. 2 domain objects. For every additional team member, you need to add 1 more role. Okay, so if it's 2 team members, then you need at least 1 additional role and 1 additional domain object. So if you have 3-member team, then you need an additional role and 1 additional domain object. All right, so it linearly goes up in requirements, although the complexity doesn't necessarily is linear. All right, the complexity it's a little slightly more than linear. Okay, so might be quadratic, maybe not exponential, but definitely not linear. In the data model, whatever data model you're going to be implementing, you'll need to obviously keep track of the user. So you'll need to have a class diagram that keeps track of stores the user, keeps track of the various domain objects, that stores all the attributes for those domain objects. You need to have some kind of relationship, a many-to-many, one-to-many relationship between a user and another user. You need to have at least a one-to-many or many-to-many user to domain, right? So between the users, you need have some relationship. Maybe somebody is somebody else's manager, okay, or maybe they're all in a group, in a team, okay. So there's a relationship between the users, or maybe somebody's following somebody, right? Or they're all are participating in the same event. Okay, so that's a relationship between a user and a user. Between users and domains, a user might be related to different domain objects, right? Somebody's created a lot of playlists. Somebody has created a lot of events, or they're gonna go out and for a camping trip, and they're inviting other folks to come. Or they're going to have a party at their house, and they can invite other folks to come. So they send out invitations to other folks. So the invitation is a domain object. You can have domain-to-domain relationships, right? Where a playlist might be a container of songs, right? Or a library of books is a container of books. Okay. So the library is a domain object, and books is another domain object, right? And you have a one-to-many relationship between them. So you need at least 1 domain-to-domain relationship. There needs to be at least 1 one-to-many and 1 many-to-many. Okay, like you might have actors and movies, right? So an actor might be in many movies, and 1 movie might have many actors, right? So you need a many-to-many relationship between actors and movies. Okay. Here's a very generic UML class diagram that tries to capture everything that we've talked about. Obviously, you don't need every single box in this generic UML diagram, but it tries to capture pretty much everything. I think I forgot 1 requirement. Generalization. Forgot. Yes. I'll explain it. You need to at least have 1 generalization, right? Where you have 2 special cases of a more generic base class, right? So here's a UML class diagram that is very generic. You have 2 types of users, for instance. The generalization doesn't need to be just for users. It could be a generalization also on the domain objects as well. Doesn't matter. Either a domain object or user, 1 generalization. That means that you need 2 types of objects, right, that are inheriting from 1 base class. right? Again, it could be on the user side, or it could be on the domain object side. Now, these are all classes, irrespective of their users, whether they're representing users or they're representing domain objects. They're all classes. Yes, these are all. But I do make the distinction, right, to specify that users with other users might have different types of relationships that domains with the other domain objects. Right, I'm just making that distinction. But everything's a class, obviously. Yes. Here you have an aggregation. A one-to-many between one user and another user. I'm sorry, a many-to-many. Here's a many-to-many of one user with another user. Here's a hierarchical relationship. Again, it's not required, but you can have a hierarchy. Maybe in a company, you might have a CEO. Everybody's an employee, but somebody has somebody they report to, right? So this self-referencing data structures allow you to do that, right? Where you can create hierarchies of users, where somebody reports to somebody, and that somebody reports to someone else, and that someone else reports to someone else, right? You create these hierarchical data structures. So this one-to-many cycle allows you to implement that. Here's another many-to-many association between users. Here's a one-to-many between a user and a domain. Here's a many-to-many between a domain object and another domain object. Okay. Here's a hierarchical, a cycle or a self-referencing data structure that allows you to create hierarchies of domain objects. Right. Maybe these are products. Right. That are inside of categories. Right. You can create a hierarchy of products. Right. Where you have a tree that you have branches of different categories within categories within categories, and you have the products at the leaves of this hierarchy. Yes. So self-referencing data structures allows you to create those kinds of hierarchies in domains. That's a very generic class diagram that tries to capture everything, but obviously for your implementation, you're not going to have everything in there. Yes. Here's just a couple of examples of some class diagrams for why is this not new wave? Oh, it's being hosted on a site that is not longer there. Right, what's the new portal? What was it? CS 5610. There it is, right? Oh no, sorry. 50. Oh, but it's. I have the image over there. Let's see. There, maybe no. No. Okay. All right. I'll make it available, but let's see. Make it bigger. There we go. Yeah, so here's an example of a mini social network where, of buyers and sellers. We have buyers and sellers are inheriting from a base class of person, right? And they have a many-to-many relationship between them of buyers and sellers sending messages to each other, right? So a to from a buyer and a seller, and buyers follow each other, right? If I find somebody who has made a great review on a product, right, and I want to keep track of that user that makes great reviews, I can follow that user, and a buyer can create a review on a product. So there's a many-to-many between a buyer and a product, right? So that a product can have many reviews from many buyers, but one buyer can create many reviews on different products, right? Same thing, a seller might keep track of many stores, online stores, and for each store, it keeps track of many products in that store. Notice that this is a one-to-many and then a one-to-many, not a map. This store is not a many-to-many. It's just a hierarchical, starts from a seller and navigates deeper into the data structure. And then here you have a cycle that captures the hierarchy of categories of products within categories. Here's another one of students and faculties sending, interacting with one another, sending messages. Here's a faculty teaching. Here's a map that says that this faculty teaches a section, but a section might be taught by many faculty. Here's a student being enrolled in many sections, but a section can have many students enrolled in it. Here you have a faculty being the author of many courses, but one course can have many authors, many faculties that are authors of that course. Here's another one of a person that is a base class for two types of users. You have an artist and a curator, right? That's and an artist can keep track of various art portfolios, right? And it keeps track of many art pieces, and they organize those art pieces in many portfolios. So each portfolio can contain many works of art, and they can create an exhibition where they can share several pieces of art with an art gallery, right? That is curated by a curator. Right? Curator curates many art galleries, and one gallery can have many curators, right? And a gallery can have many exhibitions, right? And each exhibition can have many art pieces, right? There are many types of art. You can have a hand-drawn art, or performance, or photos, or written art, or audio. And hand-drawn can be many specific types of hand-drawn art, sketches, or charcoal, or oil, depending on what the medium is. All right. So those are just a few examples of the kind of complexity that we're looking for, right? Of domain objects. So in this case, right, these are all domain objects, right? The portfolios, the hand-drawn are the exhibitions, the galleries. These are all domain objects. Okay, whereas artist and curator and person, these are all users and whatnot. Yes, right. And I just make the distinction so that we're clear what we're talking about. Features. You need some a homepage or home screen. Doesn't need to be a website. If you prefer doing mobile, or you prefer to doing some desktop application, that's fine as well, right? If you've done HCI and you've done Java Swing or whatever you prefer to use as a front end, right? It's up to you. You do need to provide some kind of login, and just plain old username and password is fine. No security measures. That's okay. We're not implementing secure, or we just want a way of somebody identifying themselves and then being able to navigate through that person's data, right? As that person is the initial navigation part that allows you to then navigate to all the data set for that particular user. Yes. There'll be some means for the user to maintain their profile information and their personal information. Some way for them to search some data that has been stored in the database, right? Maybe through some simple search, either drop downs where you can have a curated form of filtering data that you want to search through, and then it displays the data in some summary form, and then it allows you to navigate to the detail representation of that array of content. It is required that we use a third-party web service, which we're going to be creating one today here in class. So just like we're going to create a web service for ourselves, you'll be using somebody else's web service, and it can be accessed from Java or from whatever backend infrastructure you choose to use. It doesn't need to be Java. It could be if you feel more comfortable doing it in .NET, or if you prefer doing it in PHP or Python, or whatever infrastructure you feel more comfortable. There has to be a database involved, obviously, and you can either choose relational database or a NoSQL database. All right. We've mostly been just covering relational database, but when we come back from the exam, we'll start covering NoSQL databases as well, right? And if you had a chance to play around with them and you want to explore them some more, then this would be a perfect time to explore and feel more comfortable using NoSQL databases. You do have to provide some user management capability for the administrator. The administrator should be able to create a user, remove a user, update a user, and all the data that is associated to that user. The deliverable. So you do need to provide all your source code will need to be posted as a Git repository. It doesn't need to be deployed to a remote server, although if it is a web application, maybe you want to explore how to deploy it to a remote server, although it's not required. Again, doesn't have to be a website, right? It can be just a desktop application, right, or a mobile application, right? It's up to you. But the source code does need to be available in GitHub. Okay, you can choose to use the school's repository, or if you prefer to just use GitHub.com, that's even better. Either way, you'll need to invite the TAs and myself to the GitHub repository so that we can take a look at it and pull it down and try to run it locally on our machines. Again, it doesn't need to be deployed on any remote infrastructure, but it needs to be available. In that GitHub, in that Git repository, you do need to maintain a wiki, where you need to document your data model using any of these UML tools. You need to provide a class diagram that provides the cardinality, the classes, and everything there. In the wiki, also, we'll ask you to provide a data set for us to download and then populate the database, right? So that we can replicate your data set in our environments. Okay. In that data set, it'd be great if you could create for us several users so that we can test it locally on our machines. An admin with the admin role, and then four user roles, depending on how big your team is. If your team is just one, then we just need two folks, Alice and Bob. But if you have more folks in your team, we'll need a couple more people in there. Yes, and we should be able to log in as Alice or Bob or Charlie or Dan, and we should be able to go in there and see that there's plenty of data that has been populated already, right? So that we don't have to populate data. In the GitHub, in Git, in your wiki, you'll document thoroughly how is it that you want us and the TAs to evaluate your project. So for instance, you'll explain how is it that you implement it, how is it that you want us to test that we can test the profile, that how is it that we can log in, how is it that we can search, how is it that we can view a details, how is it that there's a one-to-many, right, or many-to-many, or there's a user-to-user relationship. Okay, so we're gonna look for the implementation of all these requirements, and you'll give us, right, to test user-to-user relationship. You'll ask us, log in as Alice, search for Bob, now click on follow. Now go back to your profile and see that Bob is now being followed. Or log in as Bob, click on Alice, send Alice a message. Right now, log in as Alice and check to see that Alice got a message. Yes? So you'll provide, step-by-step steps for us, the TAs and myself, to evaluate that you indeed implemented that requirement. Yes? And you'll do it for domain objects, domain to domain, one to many, for each one of the requirements. Yes? And we will follow your steps faithfully without trying to break it. Right? Once we're satisfied that this is working, we'll start randomly testing things here and there. Right? See if it's we're not going to do a stress test, or we're not going to try to deliberately try to break it. We just use it normally, see that everything is working. Right? Again, we just want to focus on the data modeling side of this. Right? We're not going to handle user validation on the front end. That's not part of this course. Right? There's a separate courses that deal with those things. We're focusing on the data model. The look and feel should look pretty finished, right? It doesn't have to look spectacular, but it has to look like that it's a finished product, okay, that you can actually use it. All right. What else? Right. So right, exactly. So these are examples of what the things we're going to test. Provide a 5 to 10 minute YouTube video of you demoing your website or product or whatever it is that you're doing, and you demonstrating to us that indeed is working. This is great if for some reason at the last minute, I don't know if for some reason it's not working, that it worked at some point. So yeah, record yourself for 5 minutes just using, and if you think you have a really cool feature that perhaps was not required, but you think it's pretty cool, that you think you should get credit for, then showcase it, right? Sell it to us and says, wow, that's really cool. We didn't ask for that, but they went the extra mile. And submit the source code. So the only thing you really need to submit to us is the URL to where the GitHub is, and in your wiki there should be instructions for us to clone it down and compile it if you're using Maven or if you're using npm or whatever you're using, right? It says type Maven clean install Maven run, and it should run, right? And you tell it what infrastructure you're using. Okay? All right. Questions?
Can you give an example of a web service? So it says going to search details pages with web service.
Yes.
So does that mean, what does that specifically mean?
Okay. So here's one that I always use as an example, and I will not today, but it's for instance OMDB. So here's an API that is freely available. Actually, no, it's not free anymore. That gives you access to movie data, historical movie data, that you can query it by providing a. I guess I need a key. Do I have a key? That you can search for movies. OMDB. Let's see. Do I have a key? I do. Don't use this key. It's my key. I pay for this key. For instance, you can say search equal Batman, and comes out. These are the top 10 results that come up with for Batman. It tells you also how many total results there are, 334. So you can paginate. You can ask, give me the second page, second, third, fourth. Right? You can paginate through a whole bunch of these results. And then, so this would be a summary page. You would display this right here. Here are 10 result set that match your query. If you want to know more about a particular movie, you can use the ID. Right? With that ID, you can search more details about one particular object. Right? It comes back with a much more larger object that is the details about this particular movie. Map and begins, and this includes ratings and releases and genre, director, writer, plot, and an image of a poster image. Right? So you can grab all this information and render it in Python or PHP or whatever it is that you choose, whatever infrastructure you use to display it, or on a phone or something, and display this in more detail.
So we're not creating this entire backend. We're just using a publicly available API.
Right. So locally in your database, you would create an entry in your database to store anything that you want to remember here, right? Because this is somebody else's data. Right? There's no need to replicate any of this in our database unless you want to remember things. Like if somebody's perusing through this database, you might want to remember that somebody likes this movie. And the only place to put that is in our database. Yes? If somebody adds a review about this movie, they're not going to allow you to post reviews to their. You'll need to store it in your own database. Yes?
Does the API we use have to be related at all to the rest of the website, or can it just be like here is a bunch of movies that have nothing to do with what I'm actually doing?
Ideally, it would have a theme. It would be part of the same theme. But yeah, I mean, folks will typically use not just one API, but maybe through 2, 3, 4 APIs that are somewhat related. For instance, depending on, for instance, I like to know what movie's playing around me. So I need a GPS API, right? That tells me, where are you? Oh, you're in Boston, right? And then it says, okay, what's playing around Boston? So now it takes you to some other API that says, these are the movies playing in Boston. So that's an example of 2 different APIs. One to identify where are you, right? And the other one to identify the movies. Or maybe a third API that displays this in a map, right? That says, oh, here's you are. So rendering that map is yet another API. Yes? It's not related, right? But it augments the user experience. I think that's too much for this class. I think just one API would be fine. Ideally, it's in the same theme of whatever you're working on. Yes? Right. So we'll be creating our own API. Okay. If we have some interesting data that we want to share with the world, it'd be nice if we could have our own API and share with the rest of the world. These folks seem to have a lot of information that everybody wants to use. Yes.
Should the API be related to the database, because the maps thing that we told that it doesn't have any database?
Right, exactly. Yeah, whatever API you choose, it would have to be something that you can store or cache in your own database that has something to do with your database. Yes? Right. So for instance, I might not cache the movie because the remote database already has the movie. Right? What I might cache in my database might be maybe the ID would be good. Right, maybe the ID, I'll keep the ID. Maybe I'll keep the title. Maybe I'll keep the poster. But the rest of the information would be redundant for me to cache all of this, right, in my own database. Right? Maybe I would cache just a couple of things so that I can make a real quick list of the things that I have in my cache. But if I want to have the details, I can just use the ID. I can always use the ID to go back and fetch the rest of the data. There's no need for me to cache everything. But all the related data, such as reviews and folks who like this movie, somebody who hates this movie, somebody who's following this movie or bookmarked the movie, all that information would have to be stored in our database. Yes? Unless the remote database provides you the capability of posting data to theirs, which is unlikely, right? You would have to do that on your own database. Yes? Okay. Right, so today we'll create a very simple API. But when we come back after the exam, we'll talk about web services in much more detail. Okay. Also, it doesn't necessarily need to, this is represented in JSON, but you can certainly use other data representation. If you prefer XML, then you could use XML instead. And also, typically you will be retrieving this data from a server on the server side, and you'll be parsing and converting that other data model, right, into this data model, into your own data model, right? And we'll talk about that as well. Okay. Any questions? All right.